Now, all of us probably have experienced performing optimization in one way or another. For example, when you're shopping for groceries, you may be subconsciously calculating what combination of things to buy to get the most value with the lowest cost. In engineering design optimization, the process is somewhat more elaborate. Before we go into it, let's take 5 seconds and see if you can think of what it would look like and what processes would be included. Okay, now let's take a look. The design phases of a system can sometimes be generalized into these 3 phases: conceptual design, preliminary design, and detailed design. During the initial design stage, engineers may build very simplified models using their intuition or past experience on the different concepts they are considering at that moment. Then, in the preliminary design stage, they may identify one of the concepts worth pursuing and then create a more refined version of this model to understand its performance more deeply. And these stages are when design optimization occurs most frequently. So, what actually happens during the optimization? We first want to understand what our optimization problem is and what is the governing phenomenon behind the problem. And this requires us to understand deeply our needs, objectives, or any goals and requirements involved in our complex system as a product as well. Then, once we've examined this optimization problem, we can start formulating it using mathematical languages and framework. We'll cover that in more detail in the next lesson, but essentially we would need to define our design variables, what we can alter, objective, and also very likely some constraints as well. Then, instead of starting right away, as a good practice, we should always perform some preliminary exploration study of our problem and the design space as well. We should try and visualize it by plotting the objective function against the different design variables so we can get a good feeling of it, and this will give us a good indication of the optimization problem we're dealing with, and we may even spot some irregularities that suggest our formulation was not correct. Then with this information, we can begin strategizing how we're going to optimize the problem. There's no one-size-fits-all solution when it comes to optimization, as there are many different approaches suitable for a variety of different situations. But in this course, we're going to talk about the different characteristics of each of the approaches that we're going to learn, the different algorithms, so you'll be able to understand and identify the most suitable one for your particular problem. Then once we've decided on the approach we want to try, we can then begin the optimization itself. But also we should keep an eye on the performance of the optimizer and any solvers that we use, because even if it turns out an answer, we shouldn't assume that everything is working perfectly, because there could always be bugs in our code or flaws in the formulation of our problem. So within the optimization step, the optimizer will first evaluate the objective and the constraints based on the first design choice that you have made, and then we will assess it against our optimality criterion. So normally during the first take, it will probably give out the solution directly. If it doesn't achieve our optimality criterion or termination criterion, the optimizer will then, based on its own algorithm, update the design variables accordingly. And this will then be fed back to the evaluation step where it sees if the performance has improved. Ideally, it should. Then overall, iteratively, it would then tend to the optimal solution and achieving the optimality condition or termination criterion that we've defined, and then finally outputting the optimal solution. And so you can see this process of optimization, this step itself is highly iterative. But again, this is not the end. If the resulting design is still somehow unsatisfactory to our needs or objectives or overarching requirements that we've defined in the first place, this may imply that the way we have formulated the problem was incorrect, or maybe our objective is actually governed by another higher level objective, which is actually what we care about. And in that case, we would need to go back to change our formulation and begin the whole process again. So you can see that there are a lot of different iterative loops in the process of engineering design optimization. And although this might sound a little bit repetitive and somewhat tedious as well, this is what happens during engineering design optimization. And remember, every time we make a mistake, we actually learn something new about the system and about our needs. So it's not so bad after all. And hopefully, ideally, at the end of the whole optimization activity, you would then end up with the optimal solution that unambiguously fulfills your needs and goals in a very robust and mathematical and rigorous way as well.